There's a signal coming from 4.6 billion miles away. And for 8 years, nobody could explain it. Not because the data was missing, not because the instruments failed, but because the thing responsible for it does not match anything in any database, any spectral library, any catalog of known matter in this solar system. Somewhere on a frozen world, at the edge of everything we know, there is a molecule that has never been seen before, anywhere, by anyone, in the entire history of astronomy. And in 2025, the most powerful telescope humanity has ever built finally admitted it could not explain what it was looking at. This is not a theory. This is not speculation dressed up for a headline. This is a documented, peer-reviewed absence, a gap in the light where something should be and isn't. Read that again. Scientists did not find a new chemical. They found a missing one, a wavelength of light that vanishes exactly where it shouldn't on not one but two separate worlds that have almost nothing else in common. One of them is Titan, a moon the size of a small planet, wrapped in a thick orange atmosphere with rivers of liquid methane. The other is Pluto, a dead, frozen rock 4 times farther from the sun, with barely enough atmosphere to register as one. 2 worlds, different sizes, different distances, different histories, and yet buried in their surfaces, something identical is absorbing light at exactly 511 micrometers, and nobody knows what it is. To understand why that single number should make your skin crawl a little, you have to understand how astronomers actually see. They don't point a camera at a planet and take a picture the way you'd photograph a mountain. They break the light apart, wavelength by wavelength, and read it like a fingerprint. Every molecule in the universe, water, methane, ammonia, carbon dioxide, has its own signature, a specific place in the spectrum where it swallows light and leaves a dark notch behind. Scientists have spent decades building a library of these signatures, cross-referencing every known compound against thousands of these absorption lines. When the James Webb Space Telescope turned its instruments toward Pluto and Titan and found a notch at 511 micrometers, the first move was routine. Check the library. Except the library had nothing, not a partial match, not a close enough, nothing. According to the research team that first flagged it, they went back through every prior study, every spectral database, every published paper that could conceivably explain the signal, and found no reference to it anywhere. That is the kind of sentence that ends careers or starts them. But here's where it gets worse. This isn't a one-off blip that could be explained away as instrument noise. It shows up in high-resolution data. It shows up consistently. And it shows up on the surface, not in the thin atmospheres hanging above these worlds. Which means whatever this is, it is physically sitting on the ground, embedded in the ice, at temperatures cold enough to freeze nitrogen solid. Think about what that means. Something is stable, present, and measurable in one of the harshest chemical environments in the solar system. And it does not correspond to a single compound humanity has ever synthesized, sampled, or theorized about with confidence. The obvious question, the one every planetary chemist is now quietly asking in private and cautiously asking in public, is simple. What is it made of? And the honest answer, right now in 2026, is that nobody knows. This is where most explanations stop. A mystery molecule, a strange headline, a shrug, and everyone moves on. But that would be a mistake, because this discovery did not happen in isolation. It landed in the middle of a much bigger story, a story that had already been quietly building for nearly a decade, about a world that scientists thought they understood and were forced, piece by piece, to admit they didn't. Rewind to 2015. NASA's New Horizons spacecraft, after a 9-year, 3 billion-mile journey, screamed past Pluto at over 30,000 miles per hour, giving humanity its first and only close-up look at a world we had only ever seen as a fuzzy dot. What it found broke the textbooks instantly. Pluto wasn't the dead, cratered, geologically frozen leftover everyone expected. It had glaciers made of nitrogen ice slowly flowing across its surface like something out of a glacial valley on Earth. It had mountains built from water ice as hard as rock at those temperatures. It had a hazy, layered atmosphere that shouldn't have been thick enough to see. And yet it was, stacked in dozens of visible bands, stretching hundreds of miles into space. This was not the corpse of a planet. This was something active, something still changing. And that single flyby, that one brief pass, was the only direct look we would get for years. Everything after that had to be pieced together from a distance. Guesswork stitched to physics, waiting for better tools. One of the people staring hardest at that data was a young planetary scientist named Xi Zhang. In 2017, based on what New Horizons had revealed, he published something close to heresy in the small world of atmospheric science. He proposed that Pluto's haze, that strange, layered fog nobody expected to find, wasn't just a cosmetic feature. He argued it was the engine of the entire planet's climate, not the gas in the atmosphere, not sunlight bouncing off ice. The haze itself, tiny particles formed when sunlight cooks methane and nitrogen into complex organic soot, was, in his model, absorbing solar energy during the day and radiating it back into space as heat at night, acting as the dominant force controlling the temperature of an entire world. It was, by his own admission, a crazy idea. Most planetary atmospheres are governed by gas. Pluto's, he claimed, was governed by smoke. His peers were skeptical. Some dismissed it outright. But Zhang made a prediction that could actually be tested. If the haze was doing what he thought, it should be glowing faintly in the mid-infrared, a specific band of light too dim for any existing telescope to detect. And then he waited. For 6 years, that prediction just sat there, unprovable, because no instrument on Earth or in orbit was sensitive enough to catch a signal that faint from that far away in that specific slice of the spectrum. Read that again. A testable scientific prediction sitting in limbo for the better part of a decade, waiting for a machine that didn't exist yet to finally be built, launched, and pointed in the right direction. That machine arrived on Christmas Day 2021, when the James Webb Space Telescope launched into space, unfolding itself like a machine out of a science fiction film, on its way to a gravitational parking spot nearly 1 million miles from Earth. It took years of calibration, competition for observing time, and careful mission planning before Webb's mid-infrared instrument, MIRI, was finally turned toward the Pluto-Charon system. And in May 2023, it captured something no instrument in human history had ever captured before, a high-resolution mid-infrared spectrum of Pluto and its atmosphere, spanning nearly 5 to 27 micrometers, a window into the planet that had simply never been open to us until that moment. What it found didn't just confirm Zhang's prediction. It validated it almost exactly. The faint infrared glow was there. The haze was radiating heat precisely the way his 2017 model said it would. In a field where hypotheses often wait 20, 30, 40 years for confirmation, if they're ever confirmed at all, this took 6. One of the researchers involved would later say, almost in disbelief, that it isn't common in planetary science to see a hypothesis validated that fast, but this is where the story stops being just a vindication and starts becoming something stranger. Because once Webb's light curves came in, measurements taken as Pluto slowly rotated, tracking how its heat signature shifted across different regions and terrains, they revealed something that hadn't been fully appreciated before. Pluto's haze wasn't just a passive layer sitting on top of the atmosphere. It was actively regulating the planet's entire energy balance, cooling it far more efficiently than gas alone ever could. Pluto, a world with barely any atmosphere at all, orbiting so far from the sun that sunlight arrives 1,000 times weaker than it does on Earth, had developed its own unique version of climate control, driven not by oxygen, not by carbon dioxide, but by organic haze particles cooked out of methane by sunlight billions of miles from where that sunlight originated. One of the lead scientists on the project put it in 5 words that should stop you cold. It's a new kind of climate, not a variation on climates we already understand. A new kind. One that, as far as we currently know, exists nowhere else quite like it in the solar system. And here is where the escalation compounds, because Pluto wasn't rotating alone in that data. Charon was right there beside it. Pluto's enormous moon, more than half its size, locked in a tight gravitational embrace so close that for years, scientists couldn't even cleanly separate the thermal signals of the two bodies. Once Webb's instruments finally entangled them, what emerged was almost uncomfortable to look at. Charon has no real atmosphere of its own. It shouldn't have organic material accumulating on its surface in any structured way. And yet its polar regions are stained a distinct reddish color, and the data now confirms why. Material is drifting off Pluto's thin atmosphere, crossing the gap between the two worlds and settling onto Charon's poles, where it reacts and darkens over time. One planet is quietly bleeding its atmosphere onto its own moon. Nowhere else in the solar system does anything like this happen. Two bodies locked together in orbit for over 4 billion years, one slowly feeding the other, and we only just watched it happen in real time. Then came the moon's own secrets. In October 2024, a separate Webb investigation digging into Charon's surface composition confirmed the detection of carbon dioxide and hydrogen peroxide, chemical signatures that hint at the moon's deep origin, potentially traced back to the same violent collision billions of years ago that many scientists believe created the entire Pluto-Charon system in the first place. One of the researchers described the confirmation of carbon dioxide as satisfying an expectation they'd held for years but couldn't prove. And even that discovery came with a warning attached. There are still gaps in the data, spectral ranges Webb hasn't fully explored yet, and researchers have openly stated that future observations targeting those blind spots could reveal even more of Charon's chemical inventory. In other words, what we know right now is not the full picture. It never is. It's a snapshot, taken mid-story, of a system that is still revealing itself piece by piece. So by early 2025, the picture already looked like this. A haze-driven climate unlike anything else observed, a moon quietly absorbing its parent planet's atmosphere and surface chemistry, hinting at a violent, ancient origin story we're still only partially reconstructing. And then the mystery molecule showed up, and everything got recontextualized. Because if Pluto's chemistry was already this unusual, already producing effects no other world produces in quite the same way, then an unidentified compound sitting on its surface stops looking like a footnote and starts looking like the missing piece of something much larger. What if the haze that's controlling Pluto's climate is chemically linked to whatever is producing that 5.11 micrometer signature? What if the same photochemical factory, sunlight cooking methane and nitrogen into complex organics, that built Pluto's climate-controlling smog, is also capable of building compounds we simply have never cataloged because no world close enough to study has ever made them before? Nobody has confirmed that link yet, but the researchers themselves have said they can't explain why two such different worlds as Pluto and Titan would share an identical, unknown chemical signature. And in science, when you can't explain a coincidence, that coincidence usually isn't one. This is not chaos. This is not a random grab bag of Pluto trivia. This is a slow, methodical unmasking of a world that spent 70 years being dismissed. First as a full planet, then, controversially, as not one, while quietly running one of the strangest chemical and climatic systems in the observable solar system. Think about the timeline for a second. Pluto was discovered in 1930. For 85 years, it was essentially a point of light, a rumor of a world mapped only in the crudest terms. It took until 2015 for a spacecraft to finally get close enough to see its surface in detail. It took until 2023 for a telescope to finally see its atmosphere's true energy signature. And it took until 2025 for scientists to admit on the record that something on its surface doesn't match anything we've ever identified. Every decade, this tiny, distant world has forced science to admit it knew less than it thought, and the implications reach far beyond Pluto itself. Xi Zheng, the scientist whose 8-year-old prediction just got validated, has already said out loud what this means for the rest of the solar system. Titan, Saturn's massive moon, has a similar nitrogen and hydrocarbon atmosphere thick with haze. Neptune's moon, Triton, an icy, geologically active world eerily similar to Pluto in composition, likely runs on comparable chemistry. If haze-driven climate control isn't a Pluto anomaly, but a pattern, a mechanism that shows up wherever you get the right mix of nitrogen, methane, cold, and sunlight, then planetary scientists may need to rethink how they model atmospheres on multiple worlds simultaneously, worlds separated by hundreds of millions of miles, unified by the same invisible chemistry. But the part of this story that should genuinely unsettle you, the part that stretches this far beyond a distant, frozen dwarf planet, is what one of the lead researchers said almost as an aside, almost too quietly, about Earth's own deep past. Before oxygen ever existed in Earth's atmosphere, more than 2 billion years ago, life already existed here. Our planet's earliest atmosphere wasn't the breathable mix we know today. It was dominated by nitrogen and hydrocarbons, chemically, structurally, disturbingly similar to what's swirling above Pluto and Titan right now. Scientists studying Pluto's haze aren't just studying a dead world at the edge of the solar system. They are, in a very real sense, looking at a live, physical model of the kind of atmosphere Earth itself once had, billions of years before anything with lungs ever took a breath. What most people are not seeing is that Pluto isn't just an alien curiosity. It might be the closest thing we have to a time machine, a preserved snapshot of the chemical conditions life first had to survive in, conditions we destroyed on our own planet the moment photosynthesis flooded the air with oxygen and rewrote the rules entirely. And this is where everything changes, because if that connection holds, if Pluto's haze chemistry really is a working analog for early Earth's atmosphere, then the unidentified molecule sitting on its surface stops being a curiosity for planetary chemists and becomes something with implications for the biggest question in all of science. How do the raw chemical ingredients of a dead world become the building blocks of a living one? Every unexplained absorption line, every unmatched compound, every strange interaction between a planet and its moon becomes a potential data point in a much larger, much older story about how life gets started anywhere at all. None of this is finished. That's the part that should sit with you the longest. The team that discovered the mystery molecule has already said future observations, targeting the parts of the spectrum Webb hasn't fully explored yet, could expand what we know even further. The haze research is ongoing, actively being compared against Titan and Triton to see how far the pattern extends. The Karen data has gaps its own researchers openly admit still need to be filled. This isn't a closed case with a tidy final answer delivered by a press release. It is an active, unfolding investigation into a world we still don't fully understand, using an instrument that has barely begun to turn its full attention toward it. Every few months, another paper lands, another prediction gets tested, another gap in the data gets filled or widens. Consider for a moment how easily this entire discovery could have been missed. Webb's observing time is one of the most contested resources in modern science. Every year, astronomers around the world submit proposals competing for a fraction of the telescope's schedule, fighting for hours to study galaxies at the edge of the observable universe, newborn stars wrapped in dust, exoplanets that might harbor water. Pluto, a dwarf planet most of the public had already mentally filed away as a settled story, had to compete for attention against some of the most spectacular targets in existence. And yet a small international team, led by researchers from the Paris Observatory and the CNRS, made the case that this frozen, half-forgotten world at the edge of the solar system deserved a look. That decision, a handful of scientists insisting that an old mystery was worth revisiting with new tools, is the only reason any of this exists. If they hadn't pushed, the unidentified molecule might still be sitting there today, undetected, its signal buried in a spectrum nobody had bothered to capture. And once they did capture it, the instrument itself became part of the story. MIRI, Webb's mid-infrared eye, was specifically engineered to detect exactly the kind of faint, long-wavelength glow that Zhang's 2017 model predicted. Light so weak, so deeply buried in the noise of the cosmos, that no ground-based telescope and no prior space telescope, including Hubble, had ever been sensitive enough to isolate it. For decades, this information existed in theory only, a testable idea with no way to test it. Webb didn't just confirm a hypothesis. It opened a door that had been sealed since the moment Pluto was first photographed as a blurry dot in 1930. Every observation that followed, the haze light curves, the Cairn separation, the mystery absorption line, became possible only because that door had finally been forced open. Now widen the lens even further because Pluto was never meant to be studied alone. It belongs to a vast, largely unmapped population of icy bodies out past Neptune known as trans-Neptunian objects. Tens of thousands of frozen worlds ranging from dwarf planets over 1,000 miles across, down to fragments the size of small cities, all drifting through the darkest, coldest region of the solar system in orbits that can take centuries to complete. Pluto and Eris are the giants of that population. Objects like Arakoth, the small, snowman-shaped relic that New Horizons photographed in a follow-up flyby after Pluto, are among the smallest and most primitive. Somewhere in that enormous, largely unexplored population, there could be dozens, maybe hundreds of worlds running the same haze-driven chemistry that Pluto just revealed, each one a potential source of the same unidentified molecule, each one untouched by any spacecraft, any telescope, any close observation at all. What was found on Pluto might not be an anomaly confined to one dwarf planet. It might be a preview of an entire hidden category of chemistry scattered across the outer solar system, waiting for someone to go looking. And think about what that means for Titan specifically, because the pairing of Pluto and Titan sharing this unidentified signature is, on the surface, a coincidence that shouldn't exist. Titan orbits Saturn, drenched in sunlight roughly 100 times stronger than what reaches Pluto, with a thick, hazy atmosphere dense enough to support rivers, lakes, and rain made of liquid methane. An alien hydrological cycle unlike anything else in the solar system. Pluto, by contrast, sits in near total darkness, its atmosphere so thin it barely qualifies as one, its surface locked in nitrogen ice at temperatures below minus 380 degrees Fahrenheit. If you designed an experiment specifically to produce two worlds with wildly different conditions, you could hardly do better than these two. And yet, somehow, both of them are producing a chemical fingerprint that has never been seen before, in exactly the same place in the spectrum. Either this is one of the strangest coincidences in the history of planetary science, or there is a shared chemical process, something about nitrogen, methane, and sunlight, however weak, that reliably manufactures the same unknown compound regardless of temperature, pressure, or distance from the sun. Neither possibility is small. Both demand an answer nobody currently has. There's also a quieter, more uncomfortable layer to this story, one that rarely makes it into the headlines. Every one of these findings, the haze, the mystery molecule, Cairn's stolen atmosphere, the carbon dioxide and hydrogen peroxide on Cairn's surface, arrived not as a single triumphant announcement, but as fragments scattered across different papers, different journals, different research teams, released months apart throughout 2025 and into 2026. Nobody sat down and unveiled Pluto's secrets in one dramatic press conference. The picture had to be assembled the hard way, one peer-reviewed study at a time, by scientists in France and California, in research institutes most people will never hear of, each one adding a single piece to a puzzle none of them could see in full. That is what real discovery actually looks like. Not a single dramatic reveal, but a slow, grinding accumulation of evidence, contested, tested, and cross-checked, until a pattern too large to ignore finally emerges from the noise. So the question isn't really what NASA already knows and isn't telling you. The real story is stranger and, in its own way, more honest than that. It's that even with the most advanced infrared telescope ever built, pointed directly at a world we've been studying for nearly a century, there is still a signature of unidentified matter sitting on its surface that nobody, not NASA, not the international teams analyzing this data, not the scientists who spent 8 years proving their own predictions right, can currently explain. Somewhere out there, 4.6 billion miles from where you're sitting right now, there's a molecule with no name, embedded in ice colder than anything on Earth, radiating a signal that doesn't match a single entry in humanity's entire chemical library. And the only honest answer anyone can give you right now in 2026 is that we don't know what it is yet. What happens when they finally find out, and what that discovery might mean for how life itself first found a foothold in the universe, is a question nobody can answer today. But it is a question that, for the first time in Pluto's 96-year history, we finally have the tools to start asking.